Hello, today we're going to do a quick review of independent and mutually exclusive events. So two events, A and B, are independent if one of the following is true. So we have three equations. We only need to show one of them is true to prove that two events are independent. So the first two are really the same, just we're switching the events A and B. So it's saying the probability of A such that B, or A given B, is equal to the probability of A. Or the reverse, the probability of B given A is the probability of B. Or we can show that the probability of A and B, so A and B occurring at the same time, is equal to the probability of A times the probability of B. What independent really means is that the knowledge of one occurring does not affect the chance of the other occurring. So one example is rolling a die twice. The probability of getting, say, a 3 on the first die and a 3 on the second die, or the first and second rolls, are independent. It doesn't matter what I rolled on the first die. What I roll on the second die is still going to be the same, no matter which one I roll first, or if I even roll a second one, right? They're independent. They don't have anything to do with each other. An example of something that's not independent is picking two names from a hat without replacing back the first one. So I choose a name from a hat, everyone has the same probability of being chosen, but once I pull that first name out and choose a second name, the chances have now changed. For instance, I can't choose the first person. So before I chose it, say there were 10 names in a hat, the probability of choosing person A would be 1 in 10. But if I chose person A, now the probability of choosing person A for my second one is 0 because it's no longer in the hat. So the chances do change if I don't replace the name. If I do put the name back in, this is now an independent, the events are now independent. So for an example, a college finds that 15% of students had taken a distance learning class and that 35% of students are part-time students. Of the part-time students, 30% have taken distance learning classes. Let D be the event that we chose a person who is a distance learning student, and let E be the event of choosing a student that is a part-time student. Are D and E independent? We have to prove one of those three equations. So given the information we have, we can find the following. The probability of D such that E is 0.3. The probability of having taken a distance learning class, given that it's a part-time student, is exactly the 30 that we have written up here. The probability of D, the probability of having a distance learning student, is 15, which is what we have up there. These two are not equal. 0.3 is not equal to 0.15. So by those definitions, the two events are not independent, which means that they are dependent. Okay, so that's how we would show it mathematically. The probability of D is such that E is not the probability of D, so they are not independent. Now let's look at what mutually exclusive means. So what it means in words is that the two events cannot occur at the same time. Mathematically, this is equivalent to the probability of A and B equaling 0. So let's look at an example. Suppose you chose a card at random from a deck of 52 standard playing cards. Let the following be events of the type choosing A. So event A will be choosing a diamond. Event B will be choosing a black card, so a spade or a club. C will be choosing a face card, so a jack, a queen, or a king. D will be an odd number, and E will be an even number. So the numbers go from 2 to 10. So an ace isn't considered a face card, and an ace isn't considered a number. Okay, so an ace is not in C, D, or E, just to be clear. So are the following events mutually exclusive? A and B. Can they occur at the same time? If they can occur at the same time, they are not mutually exclusive. So can I have a card that is both a diamond and a black card? No, because diamonds are red, So since they cannot occur at the same time, they are mutually exclusive. So the answer is yes. What about B, A, and D? So can I pull a card that is both a diamond and an odd number? Yes, there are 3 of diamond, a 5 of diamond, 7 of diamond, and a 9 of diamond. So it can occur at the same time, which means it is not mutually exclusive. What about B and D? Can I choose a card that is both black and an odd number? Yes, there are both clubs and spades of 3, 5, 7, and 9. So they can occur at the same time, which again means they are not mutually exclusive. D and E. Can I pick a number, or card rather, that is both an odd number and an even number? Hopefully that's clearly a no. A number cannot be both odd and even, which means that yes, it is mutually exclusive. C and D. Can I pull a card that is both a face card and an odd number? No, because a face card doesn't have a value, so it can neither be even nor odd because it's not a number. Since it cannot occur at the same time, they are mutually exclusive. And then for our last one, A and C. Can I choose a card that is both a diamond and a face card? The answer is yes. I have a jack of diamonds, a queen of diamonds, and a king of diamonds. So they can occur at the same time, so they are not mutually exclusive. Okay, so I think the hardest part of this is remembering that if they can occur at the same time, they are not mutually exclusive. And if they cannot occur at the same time, they are mutually exclusive. So a yes means a no, and a no means a yes. So you have to be really careful about making sure you're answering the question. Okay? So look this over, let me know if you have any questions, and good luck.